Hi, good evening. Thank you for joining. In 12 plus years of
Hmm.
experience in web and mobile application development. Today we are going to have a discussion over the different topics related to the low level design, data structure, and
Mm-hmm.
algorithm. Okay. Then we'll go
Mm-hmm.
through
Okay,
some of
perfect.
the okay. Then we'll go through some of the .NET Core concept, how we can utilize those .NET concept to solve the real time problem, and we'll try to get it more in a practical way and coding way to solve those problems. Okay. This is all
Uh,
about me.
but Ashish, just one thing to clear out. Like, I'm not a .NET developer,
Hmm. You are in
so
Java?
I'm not. Yes, yes, yes. I'm not familiar with
Okay,
.NET.
okay. Yeah, then we'll go through Java Spring Boot. Will that be okay?
Perfect, perfect.
Yeah, Java Spring Boot and aspect-oriented programming. Will that be okay?
Okay.
Yeah, yeah. Okay. I will mention accordingly. So here a criteria is given .NET Core. I will mention accordingly. It's Java, correct?
That's what I was also confused because you mentioned .NET, so I thought that might
Yeah,
be some
because
misalignment
criteria
here.
is given, so I have to follow that part, correct? Yeah.
Agreed,
So yeah,
agreed. That
that's
you are correct on your side.
okay, okay. Yeah. So thank you for joining. Let's start with your introduction. Could you please introduce yourself in terms of your skill set and
Uh,
experience?
Sure, sure. So I have somewhere around 6.5 years of experience now, and my major exposure is in backend technology. So I've
Mhm.
been working with Java Spring Boot for almost 6 plus years now, and I have built some data pipelines also using Python, and some services we have worked on in Golang as well. So majorly,
Okay.
like I have exposure to three languages: Java, Python, and Golang when it comes to backend. And when it comes to databases, I've majorly used SQL, Mongo, and in some projects we have used Graph database also, which is Neo4j. So currently I'm
Mhm.
working with Make My Trip, and I've been working with basically in an credit card product or credit card solution. And in that project, I am basically acting as the tech lead part of it. So basically, I've been managing all the architecture decisions, the design decisions that have to be taken for any new coach feature rolling out. And basically, I also go uh, give and do as an IC role. So what does that mean is like I have some features that I have to implement on my own. And as an on-call responsibility, also we have to give our some of our time in the month for on-call activities.
Okay, got it. Yeah. Thank you for introduction. Okay, let's start with the basics. Okay, could you please tell me what are the different types of data structures you are like use, and in which category you will categorize those data structures?
So by categorization, what do you mean? Like in what terms should we categorize?
Yeah, yeah. So do you know what are the different
Okay.
types of?
Yeah, so majorly like I'll just jot down what we generally use in our day-to-day life, or majorly what we are using. So we are using you can say a list or an array. Okay,
Hmm.
then for some of our use cases we have a linked list also. Then for one of our cases we use queue, but I know like there is a stack also we can say here. Okay,
Hmm.
right now we don't have a very high requirement of graph, but in one of our features we little bit consume trees. Uh, Basically, for powering the first part using the try. So we have tree and we have implemented try using that. So we do the search queries and using that try. Then I'm familiar with graph also, but like in the current project we are not using it. We have used it in Apollo 24/7
Okay,
for one
got
of our
it.
projects.
Yeah. So basically, when we discuss, so these are the this is one category. This is another category.
Hmm.
Do you know what
Agreed,
category
agreed.
you can call?
So, if you categorize this like then it is a one-to-one node in terms of array linked list. So basically, it is a linear data structure, and the graph and tree is not a linear data structure in that
Correct,
term.
correct. Got it. Okay. Okay. So when we apply any algorithm, for example, let's consider
Mm-hmm.
we are applying a search algorithm, linear
Understood.
search.
Okay.
Okay. Okay, it's searching
Mm-hmm.
one by one element on this kind of data structure versus this kind of data structure. Okay.
Mm-hmm.
What is the impact on the complexity calculation? Again, what are the
You mean the
factors
time
that you?
complexity?
Yeah. What are the key factors that you will consider while calculating the complexity?
Okay, so there are again a lot of things that comes into picture. So first, let's talk about linear data structure. Sorry. So in terms of linear data structure, if we talk about, if let's say if the first thing that we have to determine to give a complexity of a solution or a search algorithm is whether the input that we are receiving is a sorted input or whether it is a random input. By random, I mean it is an unsorted array or unsorted data structure. So if it is a sorted input, then what we can do is basically we can apply some algorithms onto the linear data structure such a way that we can reduce the search space of it by means we can basically if we talk about like binary search kind of algorithms, we can try reducing the search space in half and half and half, and we can at the best case we can achieve log n case when the input array is sorted. Otherwise, it will take otherwise, we will have to go through the complete array. We will have to search it, and then we can get the solution, which will result in a O of n solution.
Okay. And
Okay.
what will the
Mhm.
points, key consideration that you will do for the complexity calculation? And how? So, for
Uh,
example, big O or P N. Okay.
mhm,
So
mhm.
that will n represents the length of the data
Array.
structure.
Okay.
Correct. So this is one of the
Correct. Correct.
criteria. What other criteria that
Mhm.
you think?
What other criteria? Okay. Sorry, I didn't understand this question quite well.
Okay. So consider here is the length of the data structure matters. What other
Uh-huh.
factors matter when we calculate the complexity like tree and graph?
Okay. In tree and graph. Okay. I thought in array or linked list only you are asking if
No, no.
any other. Then
Yeah,
in that
yeah, I
case,
was
like it
giving one
depends what is
example.
the. Okay.
Okay,
So
okay,
in that case, like what is the depth of the tree? How many nodes we have for a tree? If it is a binary tree, if it is an n node tree. So that will basically. So for example, I'll just give you one example. Let's talk about binary first tree and an array tree. Okay, or a kind of you can say what we call an ad hoc coalescing. So what that is basically it is a try kind of structure, an array tree in which in each node you can say whether for a given value in which node it might lie, in which branch it might lie. So similar to binary search tree that we have, like the left nodes will be always smaller, the right nodes will be always bigger. So in this way, if we have some properties associated with the tree, we can definitely reduce the search space and we can best optimize it to the depth of the tree because we will have to anyway traverse to the depth on one of the sides or in one of the branches. So the best way we can achieve this is basically by reducing the height, by making it more wider so that the search space can be reduced even further.
okay, got it. Okay, so you must have implemented stack using array, correct?
Yeah,
Okay, so
correct.
let's do something different using binary tree. Okay, so
Using
let's
binary.
try
Okay.
to implement a stack using binary tree. Okay, I will explain you how.
Okay.
Okay, so let's okay, this is the unbalanced binary tree. Okay,
Unbalanced binary. Okay.
okay, so there might be one. Okay, and we can consider okay, we are what we need to do. So stack have two operations and one pointer known as
Mm-hmm.
okay top element, correct? So when you
Sorry,
pop
stack has two operations: push, pop, and what is the
and
third
one
thing you mentioned?
top element,
Top elements, PP,
correct,
basically. Okay.
correct. So what normally happens, so when we pop do the pop operation, a top element get removed from the stack, correct, which was last
Mm-hmm.
inserted in the stack, correct. So what we need to
Mm-hmm.
consider, so root will be always considered as a top element. Okay,
Acha, root should always be the top. Okay, okay.
okay, top. Okay, and we are
Mm-hmm.
performing uh okay, just a minute. Okay, so in a normally what happens when we root as it is considered to, when you do the pop operation, it will get removed. Okay, because it is a top
Mm-hmm.
element. Okay, but when
Agreed.
it get
Okay.
removed, no binary tree exists without root, correct? So what
Correct.
will
So
do,
we have to make a root.
okay, so what will do, it will compare its children. Okay,
Okay. Okay.
so it compare the value between the two nodes, which one is lower, it will take its own place. For example, this one is lower.
Okay.
But in this case, one question. Sorry for interrupting you. Just one question. Like, but if, as we mentioned, it is a stack, so the order of insertion matters. But when we are make and the second point that you mentioned is the top of the tree will always be the head.
Root.
Okay,
Correct. Root element.
root. The root of the tree will always be the head.
Correct.
Is that correct? Okay,
Correct.
so in that case, if we pop the head, then the next root should be the basically the
From its
element
children.
which was inserted. Not from its
No, no,
children,
no.
but
I'm saying so. So that's what I'm saying. So when we implementing binary tree, we are adding some clause over here.
okay, understood. So
Yeah.
it is a modified stack, you can say.
Yeah. Yeah. Yes. So what
Okay,
we are doing?
okay.
So this place become empty now. So what we're gonna do? We will compare the value between these two children. Which one
Mhm,
is lower?
mhm,
That will
mhm.
take its place. Okay.
Okay,
Now this
understood,
will become the
understood.
root element. Okay.
Okay,
Now
okay.
this place become empty now.
Understood.
Correct.
So we'll have to between these two children, we'll
Correct.
have to do the same thing
Okay.
again.
Same. You need to do the same comparison for its children. For example, this is lower.
Understood.
It will shift it to top.
Mm-hmm,
Okay.
mm-hmm,
Now this has only one children, so there will be no comparison. So it will directly
mm-hmm.
jump to the top. Correct. So you have to
Okay,
this kind of
understood.
traversing the tree till you find the leaf element. Correct.
Understood, understood. So it is a kind of
You,
rebalancing the tree. We can say
yeah,
we
correct.
are
You have to
rebalancing.
first traverse it and then rebalance the tree.
Then it is a kind of heap, right? It's not a stack, we can say.
Yeah, yeah, correct. So you have to
It's a
perform
min
this
heap.
kind of operation. Yeah, with
Okay,
time
okay.
permits, we will do the push operation as well. How we will gonna push it over here.
Okay, so
Yeah,
basically, there are three things we can say with this data filter project. One is push, one is pop, and the other is that whenever we pop, we have to do that rebalancing part as well, right?
correct, correct. You have to restructure the tree.
Uh, and this applies for push also. Basically, when we push, we have to again
Yeah,
do the
so
rebalancing
first we will
part.
go with the pop operation. If time permit, we will go through the push operation as well. Okay.
Understood.
Yeah, you understood the assignment? Any question, Priya?
Yes, yes. No, not as of now. Like the push part, sorry, pop part is clear for the given problem statement.
Yeah. Okay. So you can close the blackboard and you can start typing code over here. I think you might select Java. So I will select Java
Perfect,
for
perfect.
you.
Thank you.
Okay.
Thank you
Yeah.
so much.
And just let me know if you need any help. And you can also reopen the blackboard. Okay. Just by clicking the blackboard icon over there.
Mhm.
Okay.
Okay,
For a better
okay.
understanding. Yeah.
Sure. I'll just reach out to you, or I'll just
Sure, sure.
start
Yeah.
explaining.
Yeah, I'm here.
I'll
Yeah,
write the first basic flow.
sure, sure. Yeah. So
Okay.
what are the basic? Yeah. At the bottom, you need to design a data structure for the node, and you have to
Mm-hmm.
do that
Mm-hmm.
algorithm implementation for the traversing of array and then restructuring.
Okay. And what about the part where we create the tree? So for my
No,
question
it's
being is
consider
like
you
that.
consider that tree is already created and value are already present.
Okay,
Assume
I
that.
understood.
Assume that part.
Perfect, perfect, perfect. So we are just given the root of the tree in that case.
Correct, correct. So you will get one reference, root element
Okay,
reference.
understood. So yeah, so we node. This will have. Actually, let's not make it private. Mm.
You can take an integer value that will help you to
Uh,
just easy
okay.
comparison. Int val. Yeah, yeah. This is the node value that will be used for the comparison.
Okay, so it is a binary tree you mentioned, right?
Unbalanced binary tree.
Unbalanced, but it is binary tree.
Correct, correct. Binary tree.
Nah, okay. Then because I'm like, if it is an NRA tree and or n children tree, then in that case I would have taken a list. But as it is a binary tree, I
Yeah,
can take left and right.
correct, correct, correct.
ठीक है नली रहेगा वैसे वो इनिशियलाइज नहीं है ठीक है okay let's not let's keep it the same only so we have a tree now want to implement uh, probably left node. So, probably. Uh, yeah. So this is the one. Okay. So now the root is null. We have to rebalance the tree. In that case, we'll have to make this center, and we'll have to return our root node. Okay. We can just make that. And okay, one question. Does this tree contain both positive and negative numbers?
Yeah, it can anything. Integer, just consider
Exactly.
integer, pure integer number.
To your integer number. Okay. Okay.
Yeah,
Okay.
if like both children have a same number, you can take any of the children.
Understood. 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 So if we have to remove the node, we just remove the node, we take the children and we return. Maybe balance the complete tree on the back. Okay, perfect. Okay. So what I'm planning is this pop function will basically pop the top element, and this rebalance will basically rebalance the children, and it will return the root, the
Got
you
it.
can say the parent of there. Okay.
Got
So now we want to implement the min stack. So if left if not equals to null, sorry, if actually if left equals to null, return right. Else if right equals to null, return left. Because we know that other children doesn't exist, we can by default return it. Else we will just compare it. So if left dot value is smaller than right dot value, and if the values are equal, should we prioritize left one or the right one?
it. You can take by default, like you can consider left one. We can take.
Okay, okay. So in that case, then we will make it above it. Okay, so if the right value is smaller, then what we will do, we'll just call the rebalance tree. So our basically right value is smaller. So that means it will be the root now. So we have to return the right, and the right of the children of right will be okay. Perfect. Just a minute, let me think. Hmm. So now the right value we have to replace, and we have to recursively call this function for its children. Hmm. ठीक है. Uh, then root equals to right. Okay. And now what we'll do, right equals to rebalance. ठीक है. And now the right node is rebalance. Okay. So first we check with this guy. Okay. Before moving it upstairs, we recursively called all the. We basically started from the below. Once this is done, we come up. We check if value is okay. Then we go to the left side. The node. Now the right node equals to this. Let's go up. Can I open the whiteboard? Where is the whiteboard? Sorry. Okay,
Yeah,
sorry. Okay,
visible.
so what you told, yeah. So you told this will go up, this will become null, and then we'll have to rebalance the tree again
Correct, correct. It will go till the leaf node. Correct.
till the leaf node. So in that case, we will return. So what we will do, we will basically from let's talk this guy. It is the easiest case for us. So what we are doing is first we are past. Let's we have to make this null. we are passing the left and the right pointer. We see that both of them exist. We see which one is smaller. So we make that as the root. Let's say this one is the root that we have to make. We move it upwards. Then we call this on the children. So left dot. If we do this like that, root node, okay. Right dot read things to the head. Root equals this. Okay, remove that element top. Now that element is null. So now we have to replace another element with that. Okay. So right equals to be balanced. And then make this 10th node. It was to the right. So we moved it upwards. We rebalance the right node and then we got right equals to right. Is that correct? Uh, no, I think this is correct. Is that value? Okay. Now we have to update the signal. In that case, just change the thing. Type name. Very good. Perfect. So, yes, I was correct. Yes. Yeah, I think this should work. Let me think one. Okay. So what we are doing here is root. When we are popping, we can just blindly see if the root is empty or not. If root is equals to null, we can return null, and otherwise we can just return rebalance root dot yes, comma root dot right. Okay, let me. Shall I do a one dry run on this for the given test case? Okay.
Okay. So here you are for line number 38. Sorry, line number
Mm-hmm.
35 and 38. You have passed left and right. Okay.
Yes.
So instead,
Uh-huh.
can we just pass a single root because root dot left, root
Single
dot
root.
right?
Yes, yes, because it is the complete information of that.
Yeah. Okay. Just
Okay. Yeah.
then you have added checks over here. First you are checking
Mm-hmm.
left, otherwise you are returning right. Correct. What if both
Correct.
are null?
So in that, if both are null, then in that case, let's say, okay, let's talk with your example. Can you please open that whiteboard? Huh, sure. Okay, let's talk this leaf.
Okay.
Okay, if we have to move this upwards, let's say, then in this what will come? So if these two doesn't have any nodes, so left equals to null, right equals to null. So let's see.
How
We
will you
will
check that
first
one?
check if
So you will check that condition first or you will check that condition at last in your
which condition.
rebalance. So when both left and right are null, that condition you
Mhm.
need to check to identify whether that node is leaf node or not. Correct?
No, but we don't require that to be very honest. Like checking both the conditions at the same time. Why I'm saying that is, let's say
Uh-huh.
if our left root is null, then we are sure we always have to take the right path. Okay. If
Correct.
we say our right is null, then we always have to take the left path.
Correct. Correct.
And if both are null, then that is also covered in this case only, because let's say if both are null, then
I
our
got
right
your
will all.
point. I got your point, but just go with the execution. Okay. So like
Mhm.
right, for example, it have only one node. Consider only one node. You're
Only one
passing,
node.
okay,
Mhm.
you're passing both left and right. Okay.
Uh-huh,
Both are
uh-huh,
null.
uh-huh,
Okay.
uh-huh,
So here you are checking if left is equal to null, you're returning. Right is
uh-huh.
also null.
Correct. So, like,
So
okay, what should be the answer in case like there is only one element, and if we pop that, then the output is null, right?
yeah.
So,
So
if
you are not why you are like going down when you know that both are null, children's are null. Correct. Here you are
uh-huh,
passing both null objects. Correct.
uh-huh,
Left and right
uh-huh,
references
uh-huh.
without checking whether they are null or not.
No, but here if we pass them, like those null pointers are already handled in line number 40 and 42.
Correct. I'm
But
talking about
so,
and condition.
no, so what I'm saying that and condition is also again applied implicitly here, not explicitly. We haven't added that. Like what I'm trying to say is, else if I add this condition also, na, right equals to null and then left equals to
Like
null.
there is only root node.
There is only root node. Then in that case, if we add this condition also,
No, no, so
so what I'm
starting
trying,
first is this function will be called correct pop.
correct.
Start with this function.
Okay, let's say we just have one node. So what will happen? We will check this function will be called. The root is not null. We won't return null. We will go to the
Correct.
rebalancing branch. Okay, we will see the left. This is null. This is null. We are passing both the nulls to our rebalancing tree. Okay,
Mhm.
so what it will happen is basically in the first line itself we will return null. So that means
Okay.
basically the new node that we have, the new root that we have to take is there is no node. This is an basically null node that we have to place.
Yeah, you are returning null. Correct. And you are
Correct.
directly rebalance value return null. Instead of
Correct.
returning root element, you are returning null.
No, but
Correct.
the root element itself is null because there is only one element, right?
Correct. So, but you are not returning anything over here. So you are returning value coming from this function.
Uh-huh.
Correct. So, and from this function, you are returning null, and same you will be returning over here. So, what will this
Correct.
function will return?
It will null only.
Yeah, but we have only one root node, so that should get removed, na?
So then the output should be null, right? Or what it should be the output?
No, it should return a value that is at root.
Okay. Sorry. I thought
Pop operation
it will
means it
return the.
returns the value. Correct.
Understood. Now, actually, I was confused. So what I thought is it will return the new root node that we have
No,
to
no,
give.
no, 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 no.
Okay, understood. No.
Pop
In that
operation
case,
means it
what?
gives a value. It makes it that takes
Okay.
empty.
My bad, my bad.
That's why I
Now I
told you.
understood.
You it will be
Uh,
written. Correct.
okay, you mean the
Okay.
pop. I thought that this rebalancing part is incorrect. Okay, the element that we are returning in the pop is incorrect. We are returning the new root instead of the old root that we had to return. Yes, I
Correct.
agree.
Correct.
So okay. So we will just what we will do is uh, and okay, we have to return the complete value. No? So temp root equals to root. Okay, and then we call the rebalancing. So root equals to, and we return this guy. Is this correct? Sorry, your voice is not audible. You are in mute. I think you're speaking on mute.
I'm on mute. Yeah. So I'm just checking. Okay. Okay.
So I feel like this can be removed. This is not required.
Okay. Okay. Got it. Okay. Consider. So, do you know
Mhm.
sorting algorithms? Divide and conquer
Yes.
sorting algorithms.
No, to be very honest, I haven't implemented divide and conquer.
No, so any it's a technique. Divide and conquer is a technique. So which of the
Mhm.
sorting algorithm you are aware of?
Majorly, I have used binary search only, to be very honest. Binary search, you can
It's
say linear
sorting,
search.
sorting, sorting.
Oh,
No, no,
okay. So,
sorting.
okay, sorting. You are saying. Then bubble sort I have used majorly. Uh, Actually, I've implemented bubble sort only, to be very honest. I haven't implemented any other sort algorithm.
But you
But if
know
you
that
can,
how divide and conquer algorithm works.
no, if you can just explain me the basics of it, we can try to solve that question.
Okay,
If
so
that's
divide and
allowed.
conquer means like divide the array. So for example, if you're applying
Mhm.
that algorithm on an array, it divides into
Okay,
two,
okay.
then four,
Okay.
and so each it divides into
And
then
we sort it,
arrange it
we sort it and
yeah
merge it.
yeah sort it and merge it. Okay, in that way.
Agreed.
So I
Okay,
just
okay,
wanted
okay,
this happens on a regular sequence. So
okay,
can we
okay.
apply parallelism in this algorithm?
Uh, in binary
Like
search, you mean? Sorry,
no no
I
so
mean
this
divide and conquer
yeah
search.
the yeah chord yeah
Okay,
can
okay.
we use
Let
can we implement
let me
parallelism in this algorithm implementation?
Okay, let me think. So what we do basically in divide and conquer, as you told, it is again a recursive approach. We try to break the algorithms into smaller chunks. We sort those individual chunks and then we merge them. Okay. Or is this a merge sort that I just spoke?
Yeah, merge sort also falls in a so quick sort is one of quick sort and merge sort. There are two algorithms which divide and conquer techniques.
Acha, okay, with divide and conquer technique. Understood. Sorry, my bad. Okay. So if we have to use parallelism, so let me think. But I think what I think if let's say if we are trying to use we try to use the original array or if you have to basically sort it in place without any extra memory or extra, then what will happen if we do to if we try to use parallelism, then we might have race condition issues because multiple threads might try to write into the same location and try to swap. But let's say if we use extra spaces and with every let's say if we okay um, let's break this problem such a way that what each thread does is they have their own memory and they don't use a common memory for execution. Whatever data is required, we provide that into the thread. In that case, if we implement our threads or our algorithm this way, then I think we can achieve parallelism. But still, we can't do that in the merge part.
Okay,
If in the merge also, if we let's say if we have to generate an output new array, then we should be able to do that.
okay, got it. Okay, so if for example, if you have implemented that one in a parallelism that you suggested
Mm-hmm.
using the what are the constant you have given. So what
Mm-hmm.
about the time complexity? Forget about space complexity. You are taking extra
Okay.
space and
Then, like, if we, okay, what will be the time complexity you are saying? Let me think.
now
So, in general,
all
like
are the
in general, it will be n log n because of the sorting. Like, if we don't do the parallelism, but let's think if we do the parallelism. Okay. So first we break into two. So that's one process. Right. Okay. Then we break it into two. So it will be the maximum depth up until which we are going, and then at that point we will be doing the execution. So the maximum depth up until which we are going. 1 minute. And if we still merge it, we got all the arrays parallelly. Okay. But when we try to merge it, it will be. If it doesn't perfect, it works. I think okay. Let's break this problem into parts first. There are two parts of it. First is dividing the subarray. I guess the second part is merging the subarray. Okay. Now, as we know, the output array that we'll be getting are sorted. So merging them will take off. Let's say there are two arrays n and m. So maximum of n plus m, O of n plus m, because we have to traverse both the array and we have to insert in both of them. Uh, Okay, but let's say if we try to break it into some problems, and if we get individual ones, then that will. I think it should be the same.
Okay. So if it uses the same, so when we do with the
What is the
serial
what's the
execution,
use
yeah,
of parallelism? Yes, yes, yes. That doesn't make sense. Mhm. Okay, let me take an example. We have an array 1, 3, 2, 4. Okay. What we did, we created two array, 1 and 3 and 2 comma 4. Okay. Then we created two again array 1, 3, 2 and 4. Okay. So and can we assume like we have an infinite thread pool?
yeah,
Okay.
you can consider like 16 elements. 16 elements for the uh, array will be the max length is 16. So you can consider parallel execution for that.
But basically
Even
we
though,
have that
even
many
though, for
threads
example,
available.
we have cores for the one 16 element can be processed once, and then we can go for the next 16 element. Correct.
Sorry, can you please repeat? Your voice broke in the last part.
Even though we have limited cores for the parallel
Mm-hmm.
execution, we can take number of
Mm-hmm.
elements equal to number of cores one at a time. Correct. For example, 16 core,
Mm-hmm.
16 process 16 element, then next 16 element, then next 16 element. Correct.
Okay, understood, understood, understood. Okay, we are doing it parallelism, it's not threading. In that case, if we break it, let's say it will take O of one to break. This again will take O of one to break, but we have to execute it. I suspect in that case, if we have to get, we have like if we have a maximum of 16 elements and 16 cores available, then we should be able to do this in O of n, saying that we will only be needing the parallelism for splitting, and when we try to merge it, we can have a two-pointer or multi-pointer approach, and we can traverse both the arrays and we can merge them in a sorted fashion.
Okay. Okay. Got it. Okay. Let's jump to the. Now you said that you don't know the .NET Core. Okay. Okay. So when we go with the Spring Boot, okay. So could you
Mhm.
please explain me? Okay, I'll add the question. It might looks like a .NET Core, but it will have a same kind of functionality with the Java. Okay. So tell
Understood.
me what is dependency injection? Again, how it helps to
Mhm.
write a decoupled architecture.
Okay, okay. So the dependency injection is okay. I'll explain you in a very basic or rudimentary manner. So let's say, uh, for example, we have a class which is dependent on a connector service, which has to basically fetch some data from a repository, or let's say it has to do some API call or some XYZ activity. Now there are two methods of doing this. Either what we can do is we can create the instance of the connector inside that class. Okay, or
Hmm.
either the second way is we can pass that instance inside the constructor. Okay. Now, what dependency injection is basically, what Spring does is basically you can say it creates instances of all the classes or objects required, and basically when we use an annotation of AutoWire, it basically tries to find the implementation of that given object, and it will automatically inject that given dependency or that given instance to that object. We don't have to explicitly assign the instances, or you can say we don't have to explicitly inject the dependency onto every classes. It can be automatically injected by the Spring framework as and when the class is initialized.
Okay, got it. Okay, so for example, okay, I notification service.
Mhm.
Okay. This is the one interface on which on basis we are going to have two implementation. Okay,
Okay.
SMS,
Mhm.
email,
Perfect.
and might be WhatsApp. Okay,
Okay. 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 Understood.
so when we have kind of when we kind of registered this one survey, when we ask for the I notification service, when you going to inject
Mm-hmm.
I notification service, you are going to inject, correct? In any places, for
Mm-hmm.
example,
Mm-hmm.
uh,
Agreed, agreed.
application class.
Let's say we have a rewards processor that has to process
Yeah,
SMS rewards, SMS
correct,
notifications for
correct,
the
yeah,
rewards.
correct, correct.
Okay, okay.
Okay, so you are going to inject this kind of,
We'll,
correct?
we'll be using the interface. Agreed.
Correct, correct. Okay. So now I
Mm-hmm.
want,
Mm-hmm.
so for example, this is a injection. So how will you decide which service need to be available over here? For
So
example, I want
in that
WhatsApp
case,
over here. How will you make sure that only WhatsApp service will be get injected over here?
agreed, agreed. So in that case, what happens is like Spring creates beans of all the classes. So basically, for let's say these two classes are there, three classes are there: SMS, WhatsApp, and email. So three beans will be created by these names: SMS notification service, email notification service, WhatsApp notification service. Now, when we try to inject this dependency onto the notification service interface, it will say that there are three implementations found. So you will have to specify which implementation to take. So that can be used by basically annotating it with qualifier annotation, and that through that we can select which implementation beam we should select for this given interface.
Okay. So means like you can select using qualifier, correct? What I want to,
Mm-hmm.
so should I add two services like this one?
Sorry, I didn't. I got your last point.
For example, I want two notification. I want WhatsApp as well as email. So should I go for
Okay.
this one?
Okay, now you want implementations of two services instead of three.
Yeah.
Is it? Is it? So, what? To be very honest, like, what's a good practice here again is, we should have a factory of a notification service. So what the factory will do based on some identifier, it will basically fetch you that given implementation for the interface. So let's say we have a factory for notification service, and in that we can say the source or the destination type as email, WhatsApp notification, and as and when your request comes in, you can ask from the factory what kind of implementation you need based on your request, and you can process that. So in that way, you don't couple your code with a given interface. You can break that, or you can split that into a factory method, and in the factory method you can manage all the instances that are provided for the given interface.
Okay, got it. Okay. For example, let's take the same
Mm-hmm.
example. This application class has a, for example, hundreds of dependencies. Okay.
Okay, okay, okay.
Interface. Okay, because we have followed interface segregation method.
Huh,
Okay.
huh, huh.
So we are like created a small lot of interfaces. Now,
Okay.
so it is very difficult to manage hundred of adding dependencies, constructor.
Manually,
So what?
manually. Agreed, agreed.
Yeah. So what is the best way to refactor this code and make it maintainable?
Okay, so in that case, like again, the same approach what we discussed. Let's talk in this notification only. So let's say there are 100
But
kinds
so,
of.
so that happens when we have a kind of common kind of service. For example,
Hmm.
you will create a factory for iNotification service, and you can
Oh,
return an
so you are
object of
saying you have different objects, different,
independent.
basically
For
hundreds
example,
of
file
independent
service, yeah,
objects.
file service.
Huh.
This could be another, could be message service. There could be uh, what different service, business service. There could be
Huh,
different
huh, huh.
independent services.
Huh, 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 huh. So in that case, we can't basically. Hmm. There are independent services. Okay, and okay. So my one question is like, let's say we have 50 services, and for all those 50 services, we have different functions that have to be called. Okay, so are those 50 services we are individually declaring at the class? Because uh, after that, for example, if we have to, let's say, there are two services, one is payment service, one is notification service. The payment service, we get the checkout URL. In the notification service, we push a notification. Both have different functions that we have to implement, or different functions that we have to call. So are we having individual declarations of all the services, 50 services, or how is it?
It can be anything.
So what I'm asking is, let's say this application class is there. We have an Auto
Auto.
wired, let's say notification service,
Hmm.
uh,
For
not
one
service, let's say.
interface, we can assign it. Correct.
Yeah, perfect. Okay, now if we, let's say we have another payment service,
Yeah, correct.
and this is again a payment service. So in this case, the as we know, like if there is only one implementation available per notification or per payment service, then Spring will automatically take care of this by using dependency
Correct.
injection or inversion of control. But let's say if we have multiple implementations available, and we want basically, you can say, uh, mm, all the notification services that we have. Okay, so what we do here is we make this a list of notification services. Okay, so it will now have all the implementations for this given notification service. And if we want to limit these to some specific beans, let's say don't want to include WhatsApp in this beans, in this list of beans, then we can basically specify that using qualifier also that we don't want to include this given bean.
Okay. So you can consider only like for example. So you can
Mhm.
think on the what are the other ways to add a dependency.
Okay.
For example, I cannot do it 100 over here.
Mhm.
I can add 10 over here and remaining 90 can be added in a different way. You can think on that part.
Mhm. Okay, so my question being is, let's say let's say we have 50 services similar to this and with all different interfaces. So we can't do AutoWire for all the 50 because that is not a
Correct,
scalable
correct.
approach and
Definitely.
it will make our class very bad. Okay. But in that case, if we, let's say, if we have a, uh, so what I'm asking is like in the service where we are actually using those, or in the business logic where we are actually using those services, how are we calling or how are we calling those functions where we have to use? So in that case, like what we can do is we can use
So consider
reflection
this is
here.
the entry class. This is the entry class, and from this one
Mhm.
we are calling other services, and we are passing constructor from this one. So correct,
Sorry,
passing
can
this
you please repeat
dependency
the
from.
last part?
So for example, this is the entry
In
class.
the constructor part.
Yeah,
Uh-huh.
we received a dependency over here, and we are using
Hmm.
this dependency to pass to further methods. For example, third party service or kind of where we cannot inject our dependencies.
Okay, okay, okay. Where we
Consider we can
can't
use a
auto wire.
facade pattern. Yeah, we can use a facade pattern where we can at the
Mhm.
top level we can use the all dependencies, and at the background we
Mhm.
don't know what is going to be there. So each service is going to internally utilize different functionality where our dependency injection doesn't work.
Agreed. Okay, so in that case, let's say you are saying that the notification service might have some database dependencies, might have a Kafka dependency or some XYZ dependencies that you don't want to initialize into this class. So how will we do that?
I just
Okay,
want to pass it
so
further.
you just want to pass it further. So in that case, like if we talk this in the Spring's native way, like using beans and everything. So if we have beans defined for all our given classes, then we don't have to explicitly pass those classes into the constructor. We can basically we can get the implementation bean of that given class at the runtime, and we can use that runtime instance instead of basically passing all of the constructor or constructing it in the it at the build time.
Okay. So have you used everyone uses the annotation. Have you tried preparing
Mhm.
custom annotation?
Yes, I have made two annotations for that.
Okay. So I'm adding
Hmm.
the question. Okay, you can start. Yeah. Okay. So you have to create a custom annotation that will going to
Hmm.
log a request time and time in, time out. So when request comes to the server and when it process, okay, you have to log it. So I know we can do it in aspect oriented program directly using as a like independent logging. So I want to do it in a custom way using annotation.
Mm-hmm.
This is just an
So
example to
basically,
implement a
you can
it,
say that we want to implement an annotation that will log the request and the response of the given class
yeah,
or the
it's
given
going to
function.
call, obviously it is going to call in a both way, when start of the application, start of the request and end of the request, correct?
End of the request. Agreed. Okay. So, like, to be very honest, I don't exactly remember. I'll have to check for the syntax of how to define annotations because it's been like 2 3 months for me now. But I can walk you through the flow because I do remember how the flow and everything works. Okay. So what will have is basically at the start of the application, we'll have to scan for all the components and we'll have to find what all classes and what all functions are annotated with our given annotation. So let's say, like for example, I'll walk you through my use case, what we did, and then what use case you define, we can explore how that can be implemented. Is Does that sound good?
Yeah.
Yeah, so basically, I had a use case where we had to define an annotation for mapping that given class to a config. Basically, we had a config server where all of our config is saved in JSON. So we wanted to map that class to the given config into the config server. So we used an annotation for that so that it can automatically do the object passing, it can automatically do the validation and everything. So what it does, how it works is at the startup, we scan all the classes which have the annotations. Okay. Now we got the annotations. Now it's part. It comes to the post processing part of it. So basically, what happens? Now we can inject basically that you can say on any function call you can inject basically before call and after call method. So what that will do is that will call a specific lambda function or an interface, whatever you have function interface, whatever you have provided before and after that function is called with all the request and the response parameters that you are passing. If you want, you can add that. Okay, so now in that case, what you can do, you can define two functions. Let's say we want to log the start time and the end time, complete processing time of a given function. Okay, so what we will do,
But
we will define
you
two
should tag
functions.
that same request. For the same request, it should have a start time, because one request
Uh,
comes.
so
Yeah,
Mhm.
yeah. You got
Okay, and how it will output the data? Okay, my question is,
yeah. It
so
just
I'm asking
log
where
file. Yeah, inside that
it,
yeah annotation, you can just log it from this URL
it can just
for
log it.
request. It got
Okay,
a start time, end time. Yeah, I don't want
then
that
in
to be
that
there.
case, again, there are two or three approaches, but really multiple ways of doing this. First is we can use an MDC kind of, you can say thread based or MDC based logging. So in that case, what you do whenever you send a request or whenever you receive a request, you assign a request ID for that given thread or that given processing. So in this case, let's say if we are talking about logging for a given function, if we have the MDC available with the thread context or with the thread data, then in that case, whenever we are logging, we can associate that with the request ID that we have for the complete MDC. So in that case, we will know that whether what is the start time and what is the end time for that given one request, and we won't hodgepodge it into multiple requests.
Okay, okay. So what if we use the aspect oriented programming, or how it can be done?
If we use aspect-oriented programming, how this can be done?
So can we implement the same structure that you are given? Can we convert it into
Mhm.
aspect oriented programming? AOP
Okay, so
model.
what do you exact? Sorry,
So what? How does the current logging model works in us AOP?
in aspect-oriented programming. Mhm. To be very honest, I'm not sure of that.
Okay. So do you know decorator patterns?
Uh, Decorator, yeah, you try to facade, like facade you have, we try to decorate a given class. So okay, please correct me if I'm wrong or please tell me if I'm incorrect. A decorated pattern is, you can say, a kind of similar to a facade pattern, where you can say we decorate a given class with more functionality, and we extend the functionality of that given class.
Okay. Now go with the previous question.
Mm-hmm. Okay, so now if we want to, okay, in that case, uh, if we have to apply decorator pattern for our annotation purpose or for our logging purposes, then in that case, what we can do is we can, okay, agreed. So we can add a decorator or a wrapper on top of it, and what that wrapper does is basically it calls the subsequent processes, and before that subsequent processes, it can do all the pre-computations and the post-computations that are required for the subsequent process.
Okay. So, but yeah, so when you decorate it, so for example, how will you make sure that it will get executed before calling and after execution of that method? For example, so this is the
Mm-hmm.
API call, correct? How will you make sure that
Mm-hmm.
API method is there? I'm just giving a random. Okay.
Mm-hmm. Some
Okay. And
some
for
processing
this
is
method,
there,
we are
matlab,
like
which is
for
taking time.
yeah, log
Mm.
time. This is the one you annotation you have created. How will you make sure that this will be executed before and after of execution of this method?
Okay, if we use a decorator here. Okay, so let's say
You
this.
have added
Okay,
functionality
okay.
to this method, correct? You have added a string,
Mm-hmm.
log it. But how will you make sure that it will log it, added in the beginning and at the end?
So what I'm assuming is like let me write a pseudo code for you. Let's say we have sorry, public void log. Let's say this function is there, or process. This is the function what we have to wrap, or we have to wrap all the classes for this given for this uh, given method. Okay, so in that case, if we use a decorator pattern, then what we can do is we can basically add and with the similar implementation,
Okay, because my
we can
question is,
go.
so you said that we can add a new functionality. So new functionality can be added. It's like ki, before calling API method, just call my method, correct?
Exactly, huh?
Okay. But how will you make sure that, for example, I have created one more audit. So after successful execution of this one, this should get called. Otherwise, whatever written in this code should not get executed. For example, in any case, if we are updating something inside database, we are going to add audit it, correct? So if I'm doing
Uh-huh.
it in aspect oriented programming way, we can add a custom annotation audit. So when this API method gets successfully executed, then we're going to
Mm-hmm.
make an audit. Otherwise, we are not
Okay,
going to make
okay,
it. So
okay,
this time
okay.
what happened? We are not calling it during the beginning of the request. It is going after successful execution. Because you when you said a decorator, so can we add a functionality during beginning only, or we can add it at the after execution as well?
It can be added before and after both the execution, and it depends how you define the decorator. So let's say, like,
Okay.
what I want to say is, let's say if we have to define a process decorator for this process itself. So what we can do is, sorry, my bad. We can just call this process inside this process, and we can have a log here, log before, log after. Okay. Uh, and if we have to make it
Yeah,
generic, then
like
what?
just like this, correct? So right now for audit, I don't know what this one. For example,
You do
this is
you.
like I can tell you directly logical code. Okay, I'm
Correct,
not
correct.
writing. Audit. This is kind of code I want, but using kind of
Mm-hmm.
annotation.
Using kind of annotations.
Yeah,
So
even
one
kind
way
of
we can
exception
think
I
is
do not.
like,
Yeah.
okay. So let's say, okay. So one way of doing this is basically where we define this audit annotation at that time. Like, let's say, for example, we are defining that we have to wrap this function into our own functionality. Okay, so at the time of the definition itself, either we can give that. So what we can do is we can basically while defining the function. in the audit function or the log time function, we can define that. Or else, the other way of doing this, if we let's say if we have a common implementation for both, and let's say if there is some third requirement comes in error analysis, where you want to only log the start time, you don't want to log the end time. Okay.
Okay.
So in that case, what we can do is we can make this the log functionality in such a way that uh, preemptive. Okay. Hmm. Yeah, I think we can define different functionality, different functions, which will basically do the wrapping part of it, or different decorators for each of the annotation.
Okay. Okay. So, okay, I think we are almost closing. Just give me basic idea. Okay. So
Mhm.
when we implement anything which need to be run a parallel, so how we can implement parallelism in Java?
Okay, so there is two things again. One is multi-threading, one is multi-processing. Okay, so now as you are talking parallelism, we are talking multi-processing because we want to simultaneously
I
occupy
don't want a
two cores.
concurrency. I want independent
You
execution.
you want independent execution. Okay, so like for concurrency, we can use runnable and thread. For
Runnable
parallelism,
thread.
for parallelism, I think there is a process, and we have to spawn that process. I'm not sure of the against the syntax of it. So basically, first we have to the same way we define a thread. It will have a run method or a functional interface method that will be called by the uh, callers. Okay, so similar to that, I think there is a process class through which we can define a new process that can be instantiated to a different CPU. But in that case, we have to make sure what are the number of available CPU cores that we have and what are the threads per core that we have.
Okay. So okay. So consider we are doing some asynchronous task. Okay, maybe
Mhm,
file
mhm,
reading, calling third party
mhm,
API, maybe some kind of asynchronous operation is going on. You
mhm.
want to halt or pause or break that operation after a certain time. For example, I trigger one API call, and after 30 seconds, it should get stopped. It can be anything. This is just an example. How will you make sure that that asynchronous operation will break in that certain amount of time we have given?
Okay, so again, let me let me explain you what I understood. So we want, let's say we have an API call which spawns a process, and it takes like for around the
One
25 to
minute,
35 minutes for that
yeah.
process to, है ना? And we want to
But
kill that
not like,
process at hard 30 minutes.
yeah.
Is it? So again,
It
like
can be
one,
anything. This API call is just an example.
मतलब anything we can do DB, we can do anything
Yeah,
मतलब
correct.
competition or anything. Okay, so one way we can think is whatever thread we are spawning, in that thread itself, we can have a logic saying that uh, what something like a counter, or inside that thread we can check the execution time of that thread from the starting of its life, and we can have that logic for inside the given thread. Or else, what I think Java also offers us a way through which we can basically create a we can create new thread with a given TTL that it should be executed in this much amount of time. But that's
Okay.
yeah. Sorry, go ahead.
Okay. The first approach you are saying, who
Uh-huh.
will track the time? One thread is
The
working,
th-
and another thread is
uh-huh.
taking tracking time.
Uh-huh.
Okay.
So one thread is working and other thread is
Who is going to track the time for that thread?
which thread that tracks the
So
time
you
for
are
that
saying
thread.
that you
Okay.
said that first approach you are given, you can like track the
Mm-hmm.
time, start time until the end
Mm-hmm.
time you are going. Someone is near,
Until the
someone
end.
is orchestrator or kind of someone there who is
Mm-hmm.
going to track
Mm-hmm.
that time. So who is going to
Mm-hmm.
take care of that? If we go with
Okay.
first approach.
If we go with the first approach, so again there can be two places where we can put it. Let's see the pros and cons of both. So either that can be the responsibility of the worker thread, or that can be the responsibility of the orchestrator thread.
Hmm.
Okay. So again, if we say that if we put that logic, okay. One question before I answer that. So do we want that the if the thread is running for 30 minutes, then we have to stop it, or
I don't want. So
when we
when it started, after that it can be, so it can be pause state, runnable state, I don't care. So when it started,
exactly.
yes, I
That's
want
what my
like, for
question is.
example, it can
So
be at any state.
agree. So you want
So
30
because
minutes
you will
running,
have
right?
control only after, like when you will have control when you had start of the thread, and maybe the
Mhm.
failure and the success of thread. Correct.
Agreed,
Before,
agreed,
after that
agreed.
you will not have access. Correct.
Mhm. So basically, we
How will you
want
gain that
30
access?
minutes of 30 minutes of running time. You are saying, right?
Yeah.
So
From the
in that
start,
case,
thread dot start.
from the thread dot start. Okay. So what I feel that if we let's say if we don't want to include all the halt time or the waiting time that the thread is taking, then it makes more sense to put that logic into the worker thread.
Okay. Okay. Yeah. I think we're done with the time. And sorry for the crossing 5 minutes more. Yeah. Okay. Yeah. Thank you for your time and patience. Okay.
Thank you so much,
It was great
Ashish.
talking to you.
It was a nice conversation.